Okay, we're back. This is Techmath1. We're looking at review 1, chapters 1 and 2, and this is page 2 of the review. So here they want us to put these in scientific notation. So that means I want the number to be between 1 and 10. So I have to actually move this decimal one place over to the right. So 1.88 times 10 to the negative 1. Because think about what that would do. That would have to move it back. So actually when you're changing it from a number into scientific notation, from standard into scientific notation, then it's sort of like the rules are the other way around. So like this one, I'm going to move it 2 places to the left. I want it here, so it'll from there to there. So it'll be 9.63, so it'll be a number between 1 and 10. But then times 10 to the positive 2. All right. Okay, so this is just plug and chug, just substitute and simplify. So we're going to take 150 times 100 in the numerator and 150 plus 100 in the denominator. And we're going to get 15,000 over 250. And I think that goes evenly. I think I divided it in my calculator already. And that's just 6. So when it divides evenly, you can take a 0 out and it's 1,525ths. But then that goes evenly 6 times. So 6 or 6 over 1. All right. Let's keep going. What do we got next? Oh, substitute again. Oh, but with a fraction, huh? So 3 halves. And now I think on the test, it's going to say it wants it in lowest terms. So we've got to leave that as a 3 halves, which is going to make this one be a little bit of a pain in the butt. Because look, this is 3 halves minus 1, which means I want a common denominator there, which is going to be 2 over 2. Anytime you have 1, it's just the number over it. So the whatever common denominator you want over itself, so it's 1. All right, so now let's do order of operations. We're going to do this first, parentheses first. So 3 halves minus 2 halves is 1 half. And that's times 2 still. And then minus, and then we got 3 halves squared. So now we're going to do 3 halves squared. Be careful with that. That means 3 halves times 3 halves. Remember how we multiply fractions. Top times top, bottom times bottom, 9/4. Bunch of people accidentally told me like 6/4 on that one. So be careful to remember to multiply, not add. So we got 9/4 minus, what's 2 over 2? That's 1 again. So we'll call it 1 over 1. And now we're going to do the 1 over 1 trick again. I want a common denominator. It's 4. So I've got this. I've got 9/4 minus 4/4. And that is 9 minus 4 is 5/4. So this is in lowest terms. It's an improper fraction, but it is in lowest terms. And so that's good. That's fine. You don't have to make it 1 and 1/4. If you really want to, you can make it a mixed number and make it 1 and 1/4. But 5/4 is okay. People mix that up. They think, oh, wait, I didn't put it in lowest terms if I have it improper. That's not true. Lowest terms means you reduced it. So if that would have turned out to be 10/8, we'd have to reduce it to 5/4, and that's lowest terms. By writing it and figuring, well, 4 goes into 5 once, and so you put a big 1 outside, and then subtract 5 minus 4 to get 1 and 1/4. You're writing it as a mixed number. That isn't really, it's not any more reduced or any lower terms. It's just you're expressing it differently. All right? Okay, let's do this on, let's do the parentheses first on the top. So that's going to be 20 minus 3 times 6 over, and we can do the bottom too. These are like 2 separate entities. Negative 5 plus 7. Now we have to multiply before we add or subtract. So 3 times 6 is 18. So 20 minus 18 over negative 5 plus 7. Oh, I guess I could have did that. So we'll do the top and the bottom at the same time. So 20 minus 18 is 2. And negative 5 plus 7 is 2, and 2 over 2 is 1. So number 20 is just 1. The loneliest number. All right, then we get into one of my favorite things to do is solving algebraic equations, like finding those solutions. So let's take a look at that. 21. We got, write all of these down here. X minus 2.5 equals 4.1. 22. We've got D plus 1/6 equals 5/6. 23. We got 7 minus 12s equals 4. 24. We've got 1x. Let's put 24 up here. 24. We got 1/8 x plus 1/4 equals 7x over 8. We're going to do something special on that one. 25. We got 15 minus 6w equals 25. That's 2w. 26. 9 minus 2 minus 5h. And equals 3h. Okay, so let's work these problems. So the name of the game when you're solving equations is get 1x equals. That's all. It's a game that only has really one rule. No matter what you do to one side mathematically, you have to do the exact same thing to the other side. And so now the moves that you make are to get 1x equals. It's called isolate the variable, make sure the coefficient is 1. That's a fancy way of saying, well, get me 1x equals. So look, the variable side always drives our decisions. So I want x. I have x minus 2.5. So I think, what is the opposite of minus 2.5? Well, that's plus 2.5. So if I add 2.5 to the left side of this equation, first of all, I have to do the same thing to the right side of the equation. But look at what happens. I have x minus 2.5 plus 2.5. That's x plus 0, or just plain old x, which is the name of the game. Get 1x equals. And then, what is that, 6.6? And we're done. And you can take that 6.6 and put it right back in and check the equation if you'd like to. All right. This one. D plus 1/6 is equal to 5/6, except I don't want D plus 1, I want just D. So I subtract 1/6 from both sides, and it goes away there. I have just D. I bring down the equals to sign. 5/6 minus 1/6 is 4/6. Now see, this is not in lowest terms, because 4/6 can be reduced. So I have to divide the top by 2 and the bottom by 2. And so 2/3 is the answer in lowest terms. And on the test, it definitely says, I just was typing the test before I made this video. It says leave it in lowest terms. So I need the 2/3, not the 4/6. It wouldn't take off all the points for it. You'd only lose a point for not reducing, but I don't want you to lose any points. All right, so let's do this one. First, isolate the variable. So s is here. I want that all by itself. I have to subtract 7 from both sides. So now look, I got negative 12s is equal to negative 3. Except I don't want negative 12s. And remember, it's a game of opposites. They're multiplying by negative 12. Mathematically, what is the opposite of that? Well, that is to divide by negative 12. And so don't let your brain trick you out of the right answer. Your brain is like the movie Elf, where he gets all excited when he says Santa's coming. He yells, Santa, I'm Santa, I know him. And he freaks out and jumps like that. People's brains do that, where they see a negative 3 and a negative 12. They go, 4, I know him, I know him. The answer is not 4. The answer is 1/4, right? This is negative 3 over negative 12. So that is 3/12 positive, right? A negative divided by a negative is positive. And then I can reduce it. So it's 1/4. And so when I reduce fractions, when I'm demonstrating it, and sometimes even when I'm working out a problem, I will write that down because my brain works like your brain does, where you really focus on the 4 and it's easy to forget about the 1. I've had students even get the 3/12 right and then they write 4 down instead of 1/4. So be cautious not to make that very common mistake. Now this one is a special case because we don't have to play with fractions when it's an equation. When it's an equation, we rule the world. Remember, look, we can add 2.5 to both sides. I can subtract 1/6. I can subtract 7 and divide by -12. If I get to do anything I want to both sides of the equation, well then now I could just multiply everything by the LCD is 8. But I don't want to find it and change this into it. What I want to do is multiply everything by 8. And watch what that does. It'll make it a lot easier of an equation because the 8's cancel there. I get 1x. 8 over 4 is 2. The 8's cancel there and I get 7x. And so now I got this much easier one to work with. No fractions to worry about. So I got 2 is equal to 6x. I divide by 6. Again, don't let your brain trick you out of the right answer. It is 1/3. X is equal to 1/3, not 3. That's 2/6, right? X equals 2/6. And then I divided top and bottom by 2 to get 1/3. All right, let's keep on trucking here. Two-step equation. You can move the variables to this side and the numbers to that side or vice versa. It doesn't matter. I'm going to move my variables to the right side so I get to end up with a positive there. So 15 is equal to 25 plus 4w. And then subtract 25. And then I got -10 equals 4w. And then divide by 4. And then w is equal to -10/4, which I can reduce. What does that reduce down to? I divide top and bottom by 2. So we're talking about w is equal to -5/2. And that's fine. You can leave it -5/2. If you want to write -2.5, be my guest. You're writing it as a mixed number. You don't have to do that. It didn't tell you. You must, have your answer as mixed numbers. So, okay. On to 26, you do the distributive property on the negative. That's -2 plus 5h equal to 3h. Now we have a different thing. We're going to have to combine like terms. So this does not count as an actual step. We're just cleaning it up, combine like terms. It's like when you're going to prom and you go and clean up your car first and, put on fancy clothes. You're not at the prom, you're just getting dressed or you're just vacuuming out your car. The steps you do before. That's what we're doing right now. We're just getting this cleaned up so we can solve it like that. So, this one we started solving right away. When you're doing things to both sides of the equation, you're solving it. Right now, I did the distributive property. That was a cleanup step. So negative times a positive was a negative. Negative times a negative is a positive. That's how that happened. Now I'm still cleaning it up with combining like terms. So now I've got this. 7 plus 5h equals 3h. Now I'm ready to start solving. So I'm going to subtract 5h, get that over to that side. So we got 7 is equal to -2h. And almost done. I want 1h equals, not -2, so I divide by -2. So at the end of the day, there's like 4 lines of work, but this is really only a 2-step equation. And I cannot reduce that, so it's h is equal to 7 over -2. -7/2. Doesn't matter if you put the negative on the 2, or if you put the negative on the 7, or if you slide the negative right in front of the fraction bar like that. -7/2, it doesn't matter where the negative is, just so it's on there somewhere. Don't put it on twice. Don't make it -7 over -2, because it wasn't. It was +7 over -2. All right? Awesome possum. Let's keep going. That is doing next here? We're on 26. Okay, yeah, more of the same. Where we've got 7 plus 4 times 3d minus 1 equals 0. And 2 times x minus 4 equals 5x minus 2. And 29. Four x squared minus 25 equals 0. Ooh, a second degree. You get 2 solutions for that bad boy. All right, so this is just like the one that I just erased. I first do the distributive property. It's 7 plus 12d minus 4 equals 0. I then combine like terms, so wow, it's very much the same. 12d plus 3 equals 0. And now I isolate the variable. So that means I want to get the d all by itself. Subtract 3 from both sides. So 12d is equal to negative 3, and then divide by 12. And then d is equal to negative 3/12, which I can reduce, right? D is equal to negative 3/12, which reduces, divide by 3, d is equal to negative 1/4. So that one is negative 1/4. All right. That was 27. Lovely. Same dog, different fleas. We've got clean up, everybody everywhere. Barney, that was a Barney song. Clean up. So look, I do the multiplication. I do the distributive property. And so that's one cleanup step only. This actually had 2. I had to do the distributive and combine like terms, and then I could start working the problem. This one cleanup step, and now I'm ready to start working the problem. So doesn't matter if I get all my variables over here, all my variables over there. I just need them all on one side. Yeah, I'm going to do it this way. So now we got, what? Negative 3x minus 8 equals negative 2. Be careful. Write down the steps underneath what you're working. Don't try to shortcut it. People try to shortcut it and save a little bit of paper. Don't do that. Write the plus 8 underneath it so you literally see negative 2 plus 8. Because otherwise your brain sees negative 8 and negative 2 and puts down negative 10. But if you have a plus 8 underneath twice like this, there it goes away. You get negative 3x is equal to 6. And now we divide by negative 3. And so this is one of the problems in math with math teachers. We love to make up problems like this that work out nicely where you get x equals negative 2. But that means when you get to the problem like this where it works out ugly, negative 1/4, people just put down negative 4 because that's how they're so used to always getting whole number answers or integer answers, positive or negative whole numbers. So be cautious, don't freak out if you get a fraction. All right, so this one we isolate the variable, equals 25, and we get 1 in front of it, but this is a different duck. We got 25/4, but it's x squared equals 25/4. So now think about that. How do I get something, what's the mathematical opposite of squaring a number? Squaring a number is taking a number times itself. 7 squared is 7 times 7 is 49. But to undo it, you've got to think of 2 scenarios. Because look, I could throw the square root on this side and the square root on that side. And I'd say x is equal to the square root of 25 over the square root of 4. That is x is equal to 5 halves. But 5 halves times 5 halves is 25/4. But also, negative 5 halves times negative 5 halves is positive 25/4. So that's where this little plus or minus comes into play. There's actually 2 solutions. It's positive 5/2 and negative 5/2. So whenever you take the square root of both sides, I want you to squeak in a little plus or minus. Now, unfortunately in this class, this is a really heavy-duty algebra rule that we really try to burn into everybody's brain. But in this course, a lot of times we're ignoring the negative value because it's entrenched in the real world. And so that's called a domain restriction, where we don't want to look at it if it's negative. We're only worried about positive answers. And so then we drop that negative anyway. So later on, as we go through this course, you're going to see a lot of the times we only put down the negative version. All right, how are we doing for time? Oh, that's already 20 minutes. So the last one I'll do is the word problems.